Welcome, everybody. My name is Sean Huddy. I'm the Senior Manager of Strategic Partnerships with CERIAS. And if you haven't registered yet for our 24th Annual Security Symposium, please go. I think Mike actually put a link into the chat. Please register because it is also our 25th anniversary. We have waived registration fee, and we would love to have you all there. So we have a speaker with us today. He's with HP. His name is Patrick Schlapfer. He is a malware analyst with HP with interests in a wide range of security areas. He already focused on cybersecurity during his studies, where he developed a particular interest in malware analysis. After graduation, he worked on a scientific project at the university and built a dynamic malware analysis system for code similarity clustering. He gained further experience in incident response and threat intelligence at a Swiss bank. Since 2021, Patrick works as a malware analyst on HP's threat research team. He conducts analyses of new threats using the results to improve HP's security products and shares them with the community. And I know, personally speaking, HP does have really nice and secure products. And so the title of Patrick's conversation today, his talk with us, is going to be using endpoint isolation to track malware trends. And as you generate questions, please put them in the Q&A. And Patrick, I'm going to hand it over to you. Thank you very much for giving the talk today. We welcome you and we enjoy having you here, and take it away.
Thanks a lot, Sean, for the introduction. That's really amazing. Yeah, thanks for having me here. So first, just quick introduction on who I am. You heard most of it already. So I'm Patrick Schlapfer. I'm malware analyst at the threat research team with HP. My background is in incident response and threat intelligence, working for a bank. And besides taking apart malware binaries, I also like to track threat actors based on the domain infrastructure, which I think is quite interesting, looking at who is information, like DNS information and their certificates and all this kind of stuff. And yeah, I'm actually based in Switzerland and not in the US, just as a general information. Today's talk, I'd like to quickly introduce the HP threat research team, what we do, and what our main tasks are. Then I'd like to introduce the concept of endpoint isolation, just give a brief overview, what it is and how it works. Then most of the time, I would like to spend talking about the major infection vectors for malware distribution we're seeing at the moment, or the last half year or over the last year, apparently. Then in the end, I'll also try to give some advice how you can protect yourself. I know there are lots of advices, but I'll try to give just a few. Okay, so I'm with the HP threat research team, and we can actually split our work into two parts. So the one part is internally facing, where we collect all kind of threat data, analyze it, then we try to figure out threat trends, and then based on this information, we try to advise our product development and product management team to improve our products and just stay ahead of what's going on out there. Then a second part is more externally facing. So with all the information we collect and with all the analysis we do, we'd like to share this information as good as possible with the community. So this is not just direct community sharing, but also sharing of articles and blog posts on our website, but also sharing indicators of compromise. We share those through GitHub repositories, or also through different other services. So there are services, for example, like URL House and Malware Bazaar and ThreatFox from Abuse. So you might have heard some of those. So we try to share some data through those channels. Then another part is trying to do some education. This is mostly like customer-driven presentations where we try to show our threat protection technologies. We try to explain how they work, what they are, and how they can improve a security environment. So speaking about the data sources we use, so we collect all kinds of different threat information. So we have threat information, for example, we see all kinds of phishing sites, but here I would like to focus mostly on endpoint threats. So threats which actually make their way to the endpoint, and threats we can see and observe on the endpoint. We have some kind of endpoint protection, which gives us all kinds of information. So we have millions of endpoints, and they opted in to actually share the threat telemetry with us. The idea here is that we don't get simple hashes of files of potentially malicious files. We get a whole trace of the threat containment, which gives us a really fuller trace and information on the threats, and not just a single information. So you will get the idea when I get into endpoints and micro-virtualization. So we actually let the malware play out within a safe and secure environment, and therefore we can see how the malware behaves on the endpoint. That's about the HP threat research team. Now, let's give you an overview on the endpoint micro-virtualization, how it works and what the concept is. So the idea here is that it uses hardware-enforced virtualization technology. And the idea is that we want to create, or you can create micro-virtual machines within milliseconds. And then you run specific applications within those micro VMs. So you distinguish between risky and non-risky tasks, and you would want to run risky tasks within a micro virtual machine. So for example, if you have an Office document which was sent to you via email, or you have a PDF document, or you have different Chrome tabs, you would want to run those within a micro VM. And then as long as they're contained within the micro VM, they are contained. And if you have a malicious behavior within this micro VM, it is not able to infect the host system. So everything stays within the micro VM, nothing to steal. There's also no ability to move laterally through the network. And also persistence is not possible, because whenever a user closes the micro VM, it is destroyed and nothing is left. So this is the basic concept. But you still need to have a very good user experience. So at best, you have exactly the same user experience as if the user would run the application on the host itself without a micro virtual machine. So the application and the micro VM needs to interact and get like keystrokes from the keyboard, interact with the mouse. You have to have access to the clipboard because you may want to copy in some text and out. And for a Word document or an Office document in general, you would want to save this document on the host file system. So you need to have certain accesses. And those accesses are handled through the microvisor. So this is an analogy to the hypervisor, which manages all the micro VMs. And the microvisor uses using the least privilege principle. It uses policies to decide whether an action is allowed or an action is not allowed, to keep everything malicious within the micro VM, but still allowing a good user experience. Now let's have a look at one specific example. So in this example, we have a Word document, and the Word document in this case is infected with a malware. So oftentimes, malware requires user interaction. And this is the case because malware wants to make sure and circumvents automatic analysis systems. So in this case, the user opens the Word document within a micro VM. And because we have a user interaction, like keystrokes or mouse movement, the malware detonates and actually runs within the micro VM. Now, what we do is we collect all kinds of information, what's happening within this micro VM. So we capture like all files which are written to this. We capture all kind of network traffic, like registry behavior. So all kinds of information, even like all the specific API calls which are happening. So we get a full trace, and based on this information, we can then decide whether certain threats are more or less interesting. And based on this information, we can then correlate specific trends. So this is to give you an idea what the concept is and how we get our data and how our data looks like. I'll show a slide how it looks in the interface, in our threat intel interface. So to finish up the whole concept of micro virtualization is like we focused on isolating the risky tasks within a micro virtual machine. So we have the risky Office document or risky PDF file within the micro VM, and is not able to infect the host. But you can turn around the whole concept and say, well, let's assume we have a compromised host machine, but we still need to do some sensitive tasks. So we would want to protect an application within a specific micro virtual machine. So we don't really want to be able to capture the screen or capture keystrokes, stuff like that. So you can just turn around the concept and you have either way a safe environment, which I think is quite interesting. Okay, let's have a look how our data looks like within our threat intel dashboard. So we get all kinds of threats from all kinds of customers and clients, and one of the threats can be seen here. So we see that it's an Office document, and we see that the document was, or the threat was actually initiated by a user action. So in this case, we see that the origin of the threat is from the process Outlook. So I assume in this case, the user received an email with an attachment, and the attachment is this Excel file. And the user then opened the Excel file on purpose. So the whole behavior is then recorded, and based on the behavior, we map it to the MITRE ATT&CK to MITRE ATT&CK techniques. So this gives us an ability to actually search for specific techniques within the whole set of all threats. So we can filter them and narrow down and find the actual interesting threats which we want to analyze, which we want to further analyze. We get some additional information, like we get a process tree as well. And from the process tree, we can see that Excel then executed reg SVR32. So we can then drill down and look for specific events. So in this case, we want to see Excel executing reg SVR32. So we can also see the command line, which gives us an idea that, well, there is actually a DLL file which was renamed to a weird file ending, but this is a DLL. And we can then go even further and look at this specific behavior within the reg SVR32 process and see, well, the process loads the DLL which was passed as an argument. So this is the data we are working with. Now, let me get into the major infection vectors. So the major infection vectors can be divided into mainly like email and web browser download. So email is very, very common. We see a lot of email threats. Web browser downloads are not that common. They are becoming more and more popular lately. I'll show a really interesting example. And there are other infection vectors as well. So others are for example, if a user downloads a malicious file from a network share within an organization, or if you plug in a USB drive and there is a malicious document on it. So those are the other infection vectors, for example. So for email, I'd like to have a look at malicious Office documents. They are still around. They're not that popular as they have been in the past, but they're still around, and I think it's quite interesting to have a look at those. Then HTML smuggling. I'll talk about what HTML smuggling is, how it looks like. It became really popular over the last years. So, and then the PDF documents. So in this case, I'll mostly speak about pretty simple PDF malware, which became popular last December. So there are no exploits involved in this case, unfortunately. The latest file format we have been observing were actually OneNote documents. So actually people are sending OneNote documents as an attachment of an email. So I think this is also quite interesting to analyze. Then on the web download side, I'd like to highlight a technique called malvertising, where threat actors set up fake websites which look like real legitimate websites, but actually download malicious files. And they use search engine advertisements to lure the victims to those specific fake websites. Now, so email threats changed a lot over the last few years, and attackers are very responsive to all kinds of changes of the defense environment. Historically, Office documents were very, very popular because Office documents are just such a very convenient way. And last year, Microsoft announced a policy change, and they actually made 2 different policy changes, which shifted the whole threat landscape quite a little bit. So you can see the timeline here is actually the timeline for the Quackbot malware family. So for a long time, they were using Excel and Word documents. Then they moved to HTML smuggling last June. In December, they tried it with malicious PDF documents, and in January with OneNote documents. And we'll see what comes next. So there are all kinds of different file types which are being used at the moment. So as I mentioned, Office documents are very, very popular, or were very, very popular for a long time. And the reason for this is that you can actually use XL4 or VBA macros within Excel documents or also Word documents. So this is really convenient because you can execute code, and this code can be benign or malicious. And lots of companies rely on Office documents, and lots of companies also work with macros. I mean, I work for a bank, so I've seen a lot of Office documents, and I've seen a lot of Excel files using macros. And sometimes there are even specific security exceptions because people actually, they really, really need to work with those documents and to rely on those. In this image, we can see an extraction of XL4 macro script, and we can see that the macros use an API called URL download to file. And this is exactly what it does. So it downloads a file from a URL, and the file it downloads is a DLL. So this is basically the same threat we have seen in the dashboard just before. So it downloads the DLL with the weird file ending, and then it uses regsvr32 to actually execute this specific DLL. And now we have the threat. I think in this case, it's Emotet, which is running. Now, I mentioned that Microsoft made some policy changes, and those policy changes actually happened first in last February, February 2022. Microsoft disabled XL4 macros. So there was already a shift from XL4 to VBA macros in that time, but they also announced to be disabling VBA macros. And this happened at the end of July last year. So VBA macros were disabled for documents from untrusted sources, which has a huge impact and is absolutely amazing. But even before the policy changes happened, always a user interaction was needed. So what we can see here is what I call a social engineering image. So whenever you received such an Office document, the macros were disabled at first, of course, depending on the whole setting of your Office suite. But in most cases, it was disabled. So you get all kinds of warning messages from a protected view and a security warning. So you actually need to enable editing. You need to enable the content to run the specific macros. But the user may not know this. So the threat actor decides to, well, let them give an image, let them show that they have to activate the content and lure them that, well, the content of the document is actually not visible. It will only be visible if you enable the content, which even makes sense. But yeah, this is the lure. So they use the social engineering images. Now, after the policy changes, some threat actors shifted to different file types, but Emotet came back last November just for a short campaign, and they used the same techniques. But what they did is change the social engineering image, because there is still a way to run macro documents. So what you can do, and what they try to do, is they try to convince the user to copy the file to the templates folder of the Office suite and then reopen the document. Because in this case, you can actually execute the macros. Well, I mean, I think this is quite a complex chain and needs a lot of interaction by the user. And already after 1 week, Emotet was gone again. I think Emotet is back now since yesterday. I haven't looked at it closely, but I think they're even back with yet another Office document campaign. But macros are not the only way to execute code within the Office suite. So from time to time, there's also a vulnerability. And one of those vulnerabilities was seen last April. So it was spotted in the wild, and the vulnerability was in connection with the Microsoft Support Diagnostics tool, in particular with the URL protocol. So this allows the user to actually execute arbitrary code, and therefore they can execute malicious code on your device. We see that the threat actors adapted pretty quickly, and we've seen multiple different malware families here, just a few like Lockbot, Agent Tesla, and Remcos-Rat, who used this vulnerability to infect victims. And we can see on the timeline that it took quite a long time, and the window of the vulnerability is 63 days, which is a very long time. And if we look at companies or enterprises, in reality, it may be even longer because of the patching cycles. So quite dangerous as well. If we look at the technical aspect of this specific vulnerability, at that time, you can trigger the vulnerability by embedding an OLE object. You can embed an OLE object and decide, well, that's an external reference. And the external reference actually points to a URL. And the URL, so the web server behind this URL serves this specific payload in this example. So what we can see is we have location href, which is set to MSDT. And here we have the whole magic happening. We have different arguments like PCW diagnostic and rebrowse for file and so on. But we can see in the end, there's a lot of PowerShell code which is encoded here. So it's still in the red part. The blue part is mainly is comments, because as far as I remember, it needed to have a certain size to actually trigger the exploit. So the attacker is in this case able to run PowerShell code within the Office document, which is really dangerous. But after all, those policy changes had a real impact, and threat actors shifted to different file types. And one of those file types is HTML smuggling. So HTML smuggling became really, really popular last year. At least in the second half, it was fairly popular. And the idea here is that attackers encode a specific malicious file within the HTML document. So we have all kinds of executables or zip files or script files which are embedded and encoded within the HTML document. The HTML document is then sent as an attachment to the victim. Now, lots of enterprises have email gateway security. So this should be stopped on the email gateway, but because of the encoding, this can be quite difficult. And therefore, at the beginning, a lot of those HTML smuggling campaigns actually made their way to the victim. At the beginning, they simply used base64 encoded content. So they used base64 blobs, which were then triggered by JavaScript to trigger a download. And deep inspection analysis systems for email gateways became better. So they needed another reaction, and attackers reacted. So what they did is they split up the base64 blob in multiple different blobs, and then use JavaScript to rearrange the blob and then serve this specific download. And as you can imagine, they can do all kinds of encryption and obfuscation within JavaScript, which can make it fairly difficult for detection systems. But what happens if you open it? So if you open the HTML document, a download is triggered. So you're actually downloading a file from an opened local HTML file. And in this specific case, you download a zip file. And the zip file, it can then be extracted. And within the zip file is another like archive file. In this case, it was an IMG file. This is an image file, can also be similar to an ISO file. And at that time, it was fairly interesting because IMG files and ISO files had a triggered a vulnerability. And the vulnerability was that there is a mark of the web. And the concept for mark of the web is that if you download a file from the internet, the file gets a mark. And the mark is within an alternative data stream, which shows that this file is not from this computer, is from an untrusted source. So whenever you open the file, you get a warning message that this file might harm your computer. But in this case, if you extract the files from an IMG or an ISO file, you didn't get the mark of the web. So you didn't get the warning message, which was quite convenient to the attacker. So if you actually unpack the IMG file, you get a new folder. It's called new invoice, but you also get a link file. And this link file is most likely the one the user should open. So the link file can be, an analysis of the link file can be seen in the lower image. So we see that the link file actually triggers the new invoice.cmd, which is within the folder. This can be seen in the command line argument. And this CMD file is quite obfuscated, but in the end, it simply executes run DLL32 with the DLL, like it is just a very special file. It's called new rules.get in this case, which is actually a DLL. So this is used as an argument, and then the payload is running on the client. But what comes after HTML smuggling if this really gets detected? And this happened late last year. Threat actors moved to PDF floors. So what they do is they just send you a PDF document as an attachment. And if you open up the PDF document, you get a fairly similar image, the social engineering image, as we have seen it with the HTML smuggling or also with the Office documents. So they're still relying on a user interaction. So in this case, they let the user know that the document contains encrypted attachments. And if the user wants to receive them, they have to click the open button. And there is also a password, which can later be used to actually decrypt the attachment. So when we analyze the PDF document, which can be seen in the image, we see that there is a URL within the document. And if the user clicks the button, the URL gets opened, and the URL downloads a zip file in this case, the summary something something zip file. So this zip file is encrypted. And this has a particular reason, because if you download an encrypted zip file, the web gateway detection may not trigger because it's encrypted and the web gateway cannot look into the archive file in this case. So the user then has the password and needs to decrypt the zip file, open it, and then you have the whole game again. You can have all kinds of different infection chains following after the zip file. So such campaigns have been observed to deliver Quackbot and Iced ID, but there are also all kinds of rats and stealers which use the same technique to distribute the malware. Now, the last campaign we have seen was quite interesting. because they were using OneNote documents. And OneNote documents, in my opinion, is not really a document you share via email, but I could be wrong. I'm not entirely sure, but they still rely on the same thing, and it is quite interesting. So what they can do is they can actually embed attachments within a OneNote document. So in this case, we have a CMD file which is embedded within the OneNote document, and the social engineering image tries to convince the user to double-click the open button. But behind the open button, the attacker simply tries to hide the CMD file, which would be executed in this case. So we have seen CMD files, PowerShell files, but also all kinds of different script files and HCA files embedded within OneNote documents. So there are all kinds of different attack techniques which can be used here. In this case here, we have the CMD script as seen before. It triggers PowerShell, executes an encoded PowerShell command, which then uses a web download. It downloads a file. You can see it from the specific IP address .dat. Then it saves it as an image. It looks like an image, but in the end, it is actually a DLL again. They somehow try to convince the user here that this is a valid image file and not a malicious DLL. So we have seen all kinds of different file types being used and all kinds of different techniques. But one thing that always is in common is the human interaction part. So there's always the social engineering part. And threat actors always try to embed the social engineering images to actually trick the user into doing something specific, like activating the macros or downloading a file and decrypting the file and so on. So we thought, well, I mean, it can be quite interesting to keep track of those images, because we have noticed that those images tend to stay the same for at least the same campaign of the same malware family. But even for multiple campaigns of the same malware family, they can stay the same. Or if certain malware families are distributed and the threat actors behind them use the same builder, the document builder, to create the malicious files, they may use a very similar, if not even the same social engineering image. So what we did is we created a service which extracts all those image files from all kinds of different malicious document types. Those image files are then indexed in a database. And the idea here is that we would want to cluster those samples, identify specific campaigns, and we try to label those specific samples to get an idea what kind of malware family it is. In this image, you can actually see just an extraction of our tool. So what we have here is the first document is the initial document. So what I would want to do is I would want to find similar documents. So for each image, we calculate an average hash, which is a perceptual hashing algorithm. So this hash allows us to compare images and to calculate the actual distance of different images. This case is, in my opinion, really interesting because you see that the similarity of those documents is not always 100%. So we have two documents which are 98.44% the same. But if we open up those images right next to each other, we cannot see any difference. So what the threat actor does in this case is the threat actor changes just a few pixels to change the hash. So I know there is a possibility and a technique to use image signatures and build Yara rules to detect and classify certain malicious documents, which wouldn't work in this case because they simply change a few pixels within the document. But by using a perceptual hash, we can see the similarity and we can find a whole campaign, which was happening in this case for Quackbot. Now, let's leave the email infection vector and go on with the web downloads. So this is a topic which I think is really interesting. And the technique is called malvertising. So attackers are imitating a website, which are often quite popular software projects or quite popular software applications, which are very often downloaded. But they need to lure the victims to this specific website. So what they do is they buy search engine advertisements. And whenever you put in one specific word into the search engine, you might get an advertisement on top of all the other search results. And because the domain looks really, really similar to the official domain, it is difficult to spot the difference. And a lot of users tend to click on the first link. And in this case, they would get to the malicious website. So we made this example with AutoCity. And as you can see, the first result is actually an advertisement. And this advertisement does lead to a malicious website and not really to the official website, which serves you the good software. But in this case, the advertisement leads to the fake website, which serves you malware. In this case, it was the VDAR stealer, which is a stealer type of malware. Now, there are all kinds of different brands which are being abused this way. And an uptick started last November, and it was quite a big uptick. Like all kinds of different malware families use the same technique. So we saw at that time, we saw more than 8 different malware families. I'm sure that today the number would be way, way higher. And we tried to find similar domains. So this is part of the tracking threat actor space of the domain infrastructure, which I really like to do. And in this case, we look for very similar domains to the word AutoCity. And we can find just, in this case, I only marked 5, but we can find a lot of potential domains which are being abused in this malvertising campaigns. And in this case, they're also using the same registrar, which is quite convenient because you can narrow down and filter the result to only search to a subsequent set of domains. So in this case, we would say this is part of a wider trend of how malware is being delivered. And it's not something that is entirely new. So in December 2021, we already saw malvertising campaigns. And back then, Discord was being abused, and in the end, Red Light Stealer was distributed. In February 2022, we saw a Windows 11 operating system upgrade. I think back at the time, Microsoft announced a public version of Windows 11, so they just used this announcement to distribute malware, the threat actors. And since November, we see all kinds of different software being imitated, and the list would be way longer than what we can see here. And also the same for the malware family. We can see Iced ID had probably the biggest campaigns we observed, but there are all kinds of different stealers and rats being distributed this way. Well, we have seen lots of different threats and lots of different attack techniques, but I mean, how can you protect yourself? I split this part into 2, like first to try to do a home edition and then probably try to do an enterprise edition. And for the home edition, I can say that security awareness is really helpful. So if you know what you're doing, do you really need to install an application to pay your electricity bill or all this kind of weird stuff, which is requested by the threat actors, which you shouldn't be doing. And another thing is practicing good security hygiene. So I mean, turning on automatic updates is one thing, like having Windows being updated regularly, updating your software, updating your browser, and making backups and making sure that you can actually restore a specific backup because you really need the data in terms like in a specific case when your device gets encrypted, or also if your device breaks at some point. Also a good idea, I think, is reducing unnecessary user privilege. So in this case, one suggestion can be to set UAC to always notify. Another option is do you really need to use the admin user to work all day, or can you create another user, a second one with less privileges, and just work with the other one? This might be a good idea as well. Then one thing I think that always is forgotten is that the patching internet-facing devices. So I assume you all have an internet-facing device somewhere, and patching those devices is quite important as well. Then another part which is not really, or where the user does not have that much of an impact, is the vendor-driven security improvements. And I think they are quite impactful as well. So integrated security controls in all kinds of systems, like having secure boot or having like disk encryption, this type of stuff is really helpful for security. But also enforcing strong authentication. So if you have all kinds of web services, and you shouldn't use the same password everywhere, but if the web service enforces two-factor authentication, this adds another layer of security, which I think is really helpful. I know it's annoying from time to time, but two-factor authentication can help a lot. Now, for the enterprise side, I mean, I don't really want to give concrete advice because every enterprise looks different. Every enterprise has different requirements and different organizations and architectures. But all in all, a multi-layered security approach is something that can be really useful and is really helpful. So if you have like, you do not only have like a web gateway security, you also have like all kinds of layers, like from web gateway to email gateway, but also endpoint security, then network segregation, and so on. Then reducing the attack surface to a minimum. So asking the questions, do my employees have to browse to every website, or can we categorize the websites and then block some of those? Or can we filter emails? For example, with the OneNote case, do our users really need to receive OneNote documents as an attachment? This might not be the case. So we just block this specific file type on the email gateway. It might not be necessary in this case. Also, here's a strong authentication within the enterprise. So if you log into the VPN or to internal services, use two-factor authentication. Software management. This helps in particular when we look at the malvertising campaigns. So the first thing I do when I set up a PC, I go to random websites and download software which I'm used to. Now, you shouldn't be doing this in an enterprise. I mean, you could be using a software management system which distributes software to all the clients who need it, and have a software management where users can download the software from a trusted source. Then same here, the least privilege approach. I mean, do your users need to work with an admin user all the time? Do you have different privileges for different users? And protect what you can protect. So in this case, I mean, an additional can be the endpoint isolation. So this, for example, can help if you have like as an example, the Office vulnerability we've seen last year. So this can help to close the window of vulnerability, make a network segregation. So you don't have one big network with everything in there. If something gets compromised, potentially everything is compromised. So make network segregations and have offline backups as well. Now, I hope those advices were a bit useful. And just to wrap up the presentation, I've shown that malware is being distributed in many different forms and vectors. So I've seen a lot of different file types and a lot of different techniques which are being used. And keeping in mind that social engineering is always part of the attack. Attackers adapt quickly, they change and shift quickly their techniques. We have seen the example with the Microsoft Office vulnerability. And I know it's not always easy to protect yourself from all those techniques because they are quite diverse. So continuous improvement of your detection and protection system is really, really necessary. And keep in mind that there are complementary systems like application isolation or other stuff as well, which can help you close the security gap. I hope this was somewhat interesting to the audience, and thanks a lot for having me. If there are any questions, I'll try to answer them as good as possible.
That was very interesting, Patrick. Thank you very much. We really appreciate you being here and giving that presentation. Since I have started with CERIAS, because my background is not necessarily technology, I have learned how vulnerable we are just in everyday life. And I was so guilty of using the same passwords for everything and stuff like that, just as an individual user. And then as a business, I mean, you think about how many avenues, all those customers you touch also open up another example of vulnerability. Now, we do have a question, so I will go ahead and read that question. It's from Alex, and he asks, in addition to A records for domain names, have you seen an uptick in APTs, threat actors, taking advantage of IPv6 addressing for hosting malicious files? I imagine the advantages we get from AAAA records will also serve bad actors well, since signature-based security systems will never be able to keep up with the enormous address space. Now, to you.
That's a really, really interesting question. And actually, I don't know. I haven't seen such an uptake of threat actors using IPv6 records, so I don't really know. But this certainly is a really interesting field to have a look at. So as I mentioned, I like to track threat actors based on domain information, and the IP addresses in this case can be helpful if they're sharing the same infrastructure, but if they're moving their infrastructure, it can be quite difficult. But on the other hand, what is helpful is if you look at an IP address, you can figure out which ASN it is or which hoster it is. And threat actors tend to stay within the same hoster because they're used to it. They have payment system set up. Maybe you can even pay using Bitcoin or crypto coins in general. But I wouldn't know if there are any IPv6 attacks or not IPv6 addresses being used for hosting malicious files. I assume there is, but I'll have a look at it. That's a really interesting question. Thank you, Alex.
All right, let's see. Nope, at this time, we do not have any more questions. So I'm not going to hold you up any longer unless somebody pops in, but thank you again, Patrick. This was very interesting. And on a side note, I will be in touch with you. I'm probably going to inundate you with some information because we want to get you out here and we can do this again live when you come.
Thank you so much. That would be really
great.
amazing.
Thank you. And everybody definitely go register for the symposium. Mike put the registration link in the chat. So thanks again, Patrick. Enjoy the rest of your day.
Thanks, you too. Take care, everyone.
Thanks.
Bye-bye.
Take care. Bye.